Good morning. My name is Bhu. I am from Aspiration Energy. I am going to talk about a proposed solar solutions for Star India Private Limited. We are a company who are committed to fast forwarding to the solar future. We understand Star is a customer focused company that specializes in providing high quality chemicals, dyes and coatings for leather. In your factory we have seen a 3-ton rated boiler that is used to generate the steam for melting of chemicals and for various processes in the industry. We are also seeing there are electrical heaters that keep chemical barrels heated. We are seeing that minimum number of 8 chemical barrels are heated in a day through steam and electrical heaters. The average temperature required to heat the chemicals is 90 degrees. We are also seeing that there is no feed water heating system available for the boiler, so raw water enters into the boiler and gets heated up to whatever temperatures you require. It is producing steam, although the temperature required is only 90 degrees. It consumes more than 22 liters of diesel per day, and even if there is no need, our solution is to have solar thermal collectors. I'll explain you about the technology. These kinds of collectors can be installed on your rooftop. We have seen and studied your rooftop, and we can easily install systems like these. 6 of these is what we are proposing. I'll show you some photographs shortly. We circulate through our system till requisite temperatures are reached. And whenever your barrel heating system needs heat, we supply the hot water through the coils to supply heat to the chemical barrel heating, eliminating use of electrical heaters. In addition, when the temperatures are reached, we would circulate the hot water. We use a slight pressurization so that the water does not become steam till 110 degrees or so. That heat is exchanged through a heat exchanger, and the heat exchanger will take water from makeover tank, heat it to 90 degrees and store it at 90 degrees at your storage tank, and your boiler will take water from the storage tank at 90 degrees, almost eliminating the need for any diesel based heating in the oil in the boiler. The technology is a very simple, proven, several years proven technology called evacuated tube collectors. 2 concentric tubes with dark surface inside. The dark surface attracts heat or light, absorbs light and converts it into heat, and the heat energy is transferred to the liquid inside. We have seen temperatures of up to 250 degrees on the surface of this inside tube. But the heat, once entering in, cannot go out because there is vacuum between the tubes. The vacuum is a bad conductor of heat, so the heat gets trapped. So we can easily produce 170, 180 degrees in this water. But traditionally, these kind of collectors have produced only 60 to 70 degrees. We have modified them, we have made some system engineering to be able to produce 110 degrees of hot water to be stored in the tank, and we are delivering more than 90 degrees to a couple of customers that we are operating with. Economics, we are talking about 6 numbers of 6 kilowatt rated ETC collectors and tank. The total cost is 19.44 lakhs or 1.944 million rupees. There is a capital subsidy from Ministry of New and Renewable Energy in India. That amounts to 2.34 lakhs or 234,000 rupees. There is also a tax benefit. You can claim 100% of this cost as depreciation in the first year, being a manufacturing unit. You get a tax saving of 572,000 or 5,72,000 rupees. Your net investment hence is only 11.37 lakhs or 1.137 million rupees. What is the payback? The first is economic payback. Economic payback at the current diesel prices or current furnace oil prices is in 4 years. It's worked out thus: 36 kilowatt working for 6 hours would produce so many kilowatt hours. To convert that into kilocalories, we multiply it by 860, which is kilocalorie per kilowatt hour. So it saves 185,000 kilocalorie of heat delivered by the solar system. That amounts to 22 liters of furnace oil at 8,500, which is a very high efficiency boiler. The boiler cannot be as efficient, but very conservatively it will save 924 rupees a day, very conservatively 23,000 rupees a month, and 2.77 lakhs a year. And at current furnace oil prices, the payback is 4 years. If the furnace oil prices keep increasing the way they have increased, the payback period will be lesser than 4 years. But the life of the system is 20 plus years. I'll show you the components in a minute. After the money is paid back, every year you save a minimum of 300,000 or 3 lakh rupees every single year for the next 20 years. This is the ecological returns. You will be contributing positively to the environment by saving 60,000 kg of carbon dioxide that you will avoid pushing back the environment. We really appeal to you that this is not just economical, but this is also ecologically feasible solution. We request you to consider this positively and give us a purchase order. What have we done so far? We have implemented such systems on factory rooftops already. Here is a 35 systems that have been working for about a year now in Sriperumbudur near Chennai. All the systems are mounted on distributed load structures. The load itself is distributed over several trusses and purlins. The average load per square meter is less than 40 kg. All the components are hot dip galvanized with life expectation of 20 years. All the components are designed for the wind speeds that are expected in a place like Chennai. This is another installation where we have installed 105 such systems. 830 kilowatt solar installation, the largest solar installation for process heat on factory rooftops in the world. This is consistently producing 100 plus degrees, delivering heat between 70 and 90 degrees for their processes for the past 5-6 months. For our pioneering work, we have received awards from Ministry of New and Renewable Energy. I request you to favorably consider this option and hence request you for a purchase order for this system. Thank you very much.